Introduction. We feel hot in summer and cold in winter. We wear woolen clothes during winter when it is cold outside. Woolen clothes keep us warm. We prefer to wear light-colored cotton clothes when it is hot. These give us a feeling of coolness. How do we know whether an object is hot or cold? In this chapter, we shall try to answer some of these questions. Hot and cold. In our daily life, some objects are hot and some objects are cold. By using certain temperature, we can change the state of the object from hot to cold. A reliable measure of the hotness of an object is its temperature. Temperature is measured by a device called thermometer. Some of the examples of hot and cold objects are hot, tea, frying pan, cold, ice cream, fruit juice. Activity. Take 3 large mugs. Label them as A, B and C. Put cold water in a mug A and hot water in mug B. Mix some hot and cold water in mug C. Now, dip your left hand in mug A and right hand in mug B. After 2 or 3 minutes, put both the hands simultaneously in mug C. Left hand feels hot in mug C and right hand feels cool in the mug. Measuring temperature. Temperature is measured with the help of thermometer. The thermometer that measures our body temperature is called a clinical thermometer. A clinical thermometer consists of a large narrow uniform glass tube. It has a bulb at one end. The bulb contains mercury. Outside the bulb, a small shining thread of mercury can be seen. The scale used is Celsius scale, indicated by degree Celsius. A clinical thermometer reads temperature from 35 degrees Celsius to 42 degrees Celsius. Laboratory thermometer. Laboratory thermometer is used to measure the temperature of objects. The range of laboratory thermometer is generally from -10 degrees Celsius to 110 degrees Celsius. While using laboratory thermometer, it should be kept upright, not tilted. Bulb should be surrounded from all sides by the substance of which the temperature is to be measured. The bulb should not touch the surface of the container. Laboratory thermometer activity. Take some hot water in a beaker or a mug. Dip the thermometer in water so that the bulb is immersed in water but does not touch the bottom or sides of container. hold the thermometer vertically. Wait till the mercury thread becomes steady, not the reading. This is the temperature of water at that time. Transfer of heat. Heat is transferred by three processes: conduction, convection, and radiation. Heat transfers from a hotter object to a colder object. The process by which heat is transferred from the hotter end to the colder end of an object is known as conduction. In solids, heat is transferred by the process of conduction. In liquids and gases, heat is transferred by convection. No medium is required for transfer of heat by radiation. Transfer of heat. Activity 1. Take a rod strip of metal such as aluminum or iron. Fix a few small wax pieces on the rod. These pieces should be at the same distance. Clamp the rod to a stand. Now heat the other end of the rod. As the rod is heated, wax pieces begin to fall from the end nearest to flame. This shows that heat is transferred from the end nearest to flame to the other end. Convection. Example. In the coastal areas, during the day, the land gets heated faster than the water. The air over the land becomes lighter and rises up. The cooler air from the sea rushes in towards the land to take its place. The warm air from the land moves towards the sea to complete the cycle. The air from the sea is called sea breeze. At night, it is exactly the reverse. The water cools down slowly than the land, so the cool air from the land moves towards the sea. This is called land breeze. Radiation. The transfer of heat by radiation does not require any medium. For example, the heat from the sun reaches the earth by radiation. A hot utensil kept from the flame cools down as it transfers heat to the surroundings by radiation. All hot bodies radiate heat. When this heat falls on any object, a part of it is absorbed by it, a part is reflected back, and a part is transmitted. The temperature of object increases due to absorbed part of the heat. Activity. Take two identical tin cans. Paint the outer surface of one black and other with white. Pour equal amounts of water in each and leave them in the mid-sun for about an hour. Measure the temperature of water in both the cans. The temperature of black-colored can is higher. Now, fill both the cans with hot water. Leave the cans in a room or in a shade. Note the temperature of water in both the cans after 10 to 15 minutes. The temperature of white-colored can will fall more than black-colored can. This activity shows that dark surfaces absorb more heat than light surfaces.